You're listening to the Archaeology Podcast Network.
You're listening to the Archaeology Show. TAS goes behind the headlines to bring you the real stories about archaeology and the history around us. Welcome to the podcast.
Hello and welcome to the Archaeology Show, episode 327.
On today's show, we talk about 3 different ways that ancient DNA analysis is helping us understand our genetic past.
Let's dig a little deeper, find out how hot those Neanderthals were. Welcome to the show.
Hello.
All right, so we have 3 news articles for you this time around.
Mm-hmm.
And yeah, they're all pretty cool, I think. Plus, we've got a good stuff coming out because it's springtime.
Yeah, they are really cool. And I don't think we even did this intentionally because I found a couple of the articles and you found one of them. And like we were researching at different times, but somehow these all 3 have like a bit of a DNA connection.
Yeah.
And I also kind of think that like we're going to start seeing more and more DNA studies come out as the technology to study DNA, ancient DNA, becomes more and more prevalent and gets better. You know, I think that ancient DNA has so much to tell us about whatever remains we find in the past. So I don't think these studies are going to stop coming, and they're going to come faster. So I'm excited about that. I love evolutionary biology. It's like the best.
It's really fun because you can tell so much about, I don't know, just like deep time by studying current DNA and these DNAs that are extracted from remains. And it's just so fascinating what you can actually do with that if you've got enough computing power.
Yeah. And it's like very small things. Like you can make very small individual conclusions. You can draw those. Like this first story is just a very small, very individual DNA conclusion that they were able to come to. But you can also study like entire populations, or as we'll see in the final study, like entire, species of people, and draw conclusions there too. So it just, as we go in this episode, the DNA studies are going to get like bigger and bigger, basically.
Yes. Or
maybe not studies, because the third one is more of an idea, but yeah. Anyway.
All right. So what's the first article?
Yeah. So first article. Okay. So this is called Anglo-Saxon Burial Holds an Older Sister Cradling Her Little Brother After They Both Died 1,400 years ago, possibly of an infectious disease. And that was published in Live Science.
Yeah. And I got to say, they're only saying possibly of an infectious disease because they actually don't say in the article how they died. Which is probably because they can't tell how they died looking at the bones, which probably means disease.
It probably does mean disease, but
they both could have been suffocated by their mother too. I mean, we just don't know that.
They could have. But that is a very good point, though. They could have died in a fire, right? But from smoke inhalation, that's not going to leave a mark on the body, you know? So there's a lot of ways that people can die at the same time. That is not disease, but it's an easy like conclusion to jump to.
You got to kind of go with the odds, it's probably not something extraordinary.
Yeah.
It's probably something ordinary.
It probably
right.
Is.
And disease was ordinary.
Disease was ordinary for sure.
So anyway, the 2 children are buried together. And what's important about this current article, other than the fact that it was announced on the Time Team podcast in April of this year, which I thought was really cool.
I know. I thought that was cool
but too. And if you don't know what Time Team is, I mean, if you search Time Team here in the United States, you'll find I think it was a limited, I think they ran for 3 seasons.
Yeah, very short run.
Yeah, it was a pretty cool show, but the one in England has been running for 3 decades.
Yeah, it's still going, right?
Yeah, I have a business doing something completely not archaeology, and I was talking to one of the people that runs the UK portion of this business and mentioning I was a former field archaeologist. And she's like, "Oh, have you ever heard of Time Team? I watch it all the time." It's like you and everyone else in Britain.
Yeah, people
crazy.
love that show in the UK, and I love that there's a public, avenue for archaeology over there. We don't really have something like that here in the United States, but
so anyway,
so there's us. We're the Time Team of the US, right?
I don't know if I'd say that. Yeah,
just kidding, not so much at all.
So anyway, the interesting bit about this and what ties it into DNA is that when they first uncovered these guys a couple of years ago, they didn't know much about them. And now since then, they have confirmed that through DNA analysis, they're actually siblings. They didn't know that. I think there was a guess, but they didn't know that.
When you see 2 people buried together, you're kind of guessing.
Children.
Yeah, specifically 2 kids. Probably, but it's hard to know. So the burial dates to the second half of the 7th century, which is around 1,400 years ago. And the grave was discovered in 2024 in Charrington, southwest England. So that's not discovered too long ago, actually, fairly new in the world of archaeological discoveries anyway.
Yeah, the boy aged about 7 to 8 years old, and the girl was teenager.
Yeah.
So he's kind of like a younger teenager, it sounds like.
Yeah.
Yeah.
And the boy was buried with an iron sword.
Because you can't start him too early.
Right. Look, things were important back then, and swords were one of them.
And the girl was buried with sewing materials. Let's not profile the Middle Ages here.
I know we've made a lot of strides forward in understanding what male and female roles were in the past, but like sometimes men fought with swords and sometimes women sewed, and like that's okay too.
Yeah,
that is okay too. That definitely did happen.
Yeah, it's true.
But the girl was buried with not just sewing material. She also had a necklace and a little workbox, which had the sewing stuff in
likely
it.
held sewing materials.
Yeah, I know. Okay, fine. Yes, that's fine. That is okay.
Yeah. All right. So as we mentioned, the burial was featured on Time Team. That's like an episode of Time Team, which is kind of cool. And then they announced some of their discoveries. Which the other cool thing about Time Team is they're not just like archaeologists and people that go out and do digs for TV. They publish.
Yeah.
They do research. They actually publish
And
their
they publish.
research. Yeah. And it's very well done from a scientific and entertainment standpoint.
Yeah. And so they wanted to do some DNA testing on these two individuals to find out if or how they were related. And those tests were conducted by scientists at the Francis Crick Institute.
And I think that's fun because Francis Crick and James Watson worked in England, where they discovered basically the structure of DNA.
The helix.
Yeah, double helix.
Yeah. Yep.
Which I was just reading a completely different book. I think it was at Cambridge is where they were. And that's where Stephen Hawking is. I'm reading a book about Stephen Hawking right now.
Oh, yeah.
And he's a physicist, if you don't know who that is. Or was. And rumor has it they actually invented the double helix in the bar across the street from the lab.
I love that.
They were having drinks. And,
I love it.
Yeah. It's not the official story.
Right.
Yeah.
That's great. So, like we said, this was announced on an episode of Time Team, and it was done by Jacqueline McKinley, and she was able to actually confirm that these two were brother and sister using DNA analysis.
Yeah, they seem to have been buried at the same time because you can tell that with just soil maneuvering and how they were together and
the way
and
the bones
like
are laid out and all that. Yeah.
It would be difficult to have somebody die and then dig that person's burial up without any sort of coffin or anything, and then put somebody else in their arms of the decayed person.
Yeah.
It would be not only disgusting and sick, and nobody's going to do it, but really hard.
Very difficult.
Yeah, so it's pretty obvious that they were probably buried together.
Yeah.
Or at least very close in time.
And there's a beautiful artist rendering of what they would have looked like when they were first laid to rest in the article. So definitely click on the link and go check that out. Yeah,
the cool thing is they have there's a picture of the actual burials too. And it's just amazing what people can tell with experience looking at stuff because
it looks like a jumble.
It's just like a jumble. It's it's actually the term for it is a palimpsest when you've got different layers that are squished down on top of each other.
Yeah.
And that's just what happens through time. But they can tell just because of the positioning that it looks like the girl was positioned, like you said earlier, facing her brother, but then slightly elevated as if propped up on pillows. And they would say something like pillows because there's no evidence of those now.
Right.
They're gone completely.
Organic material is going to decompose 100%. So, yeah. And because of the way she's positioned facing the boy, it's almost like maybe she had a caregiving role for him. And so speaking as an older sister with 3 younger siblings, one of which is 8 years younger than me, 8.5 years, like I can totally, like I had a caregiver role when I was a teenager for them. I did a lot of babysitting for them. And so like,
but your brothers, would you want to be buried like cradling your brother for the rest of existence?
Oh my gosh, but just think of like the sadness of that moment,
That's true.
You know? Yeah. Like, I mean, yeah, they annoyed the crap out of me and they did back then and they still do. Right. Sorry if you guys are listening. I know you're not though.
Right.
Anyway.
Another source of annoyance.
Right. But yeah, like I helped a lot to take care of them. And my parents certainly would have buried us like this in this time frame, in this place, because we were a very close family. So I can totally see how that would be what this was in this scenario. And
because of all that, the researchers were leaping to a few conclusions here. Yeah. Because of the dual nature of the burial and the fact that there's no external wounds or anything you can see on the bones, at least nothing that's survived time, they just assume it was an illness, but not only that, but a fast-acting infectious disease that just like took them both down. Yep. And they said it's possible that the sister contracted the illness from the brother because if she was a caregiver, maybe he was sick, but it's possible they were just both living in a cramped, tight house together and both got sick.
Yeah. I mean, I think it's really hard to say that the boy gave it to the girl because you just don't know who would have brought it into the house. In fact, when you're talking about who would be more likely to leave the house, I would think that the older sibling would be the one who is going out and doing things in town and coming back in and potentially bringing things back in with them. So like,
could have,
I think that's a conclusion that they're definitely jumping to that you can't really say, and they don't have evidence. They're just spitballing.
Well, and I think a teenage girl in not only that time period, but even now would be in the role of a secondary or tertiary caregiver for their younger siblings. Everybody knows that, they're going to do some babysitting, right?
Oh, yeah.
Boys or girls, really, at this point.
Yeah, for sure.
But even back then, she would have definitely been in a caregiver role, whether he was sick or not. So if they both died from the same thing, whether or not she got it from him is not really important.
It's not. Yeah.
She would have been a caregiver either way, and she probably they either contracted it at the same time or one did get it from the other, but it doesn't really matter.
Yeah. Yeah.
So, anyway, the exact cause of death can't be confirmed. And part of that reason is because some deadly diseases that were known at that time, like sepsis or meningitis, actually leave no detectable DNA trace. There's just not enough time for it to have some sort of an effect on your DNA, first off, and also your bones or anything else that we can actually see.
Yeah, exactly. And there's even more diseases than just that would take you so quickly that there's just no evidence left behind. So it does seem like the likely cause.
The other interesting thing here is that other Anglo-Saxon burials nearby that are double burials with
burials.
2 people, they've never shown any close genetic relationships in these burials. So they're buried together for some other reason, not because they're genetically close.
Maybe because digging one hole is easier than digging two.
They die at the same time. I'm not digging another hole.
Not to be like crude about it, but like you do have to take that into account.
Yeah, digging is hard.
Digging is hard.
Take that from 2 archaeologists.
It is.
Yeah, if I can dig one hole instead of 2, I'm going to do it.
Yeah, I know. And if nobody's objecting, then for sure. So these other burials support the idea that Anglo-Saxon households included extended family, fostering, and adoption. Okay, so maybe not just like throwing 2 people who don't know each other in one hole, but that a family is made up of not just people who are genetically related. And I can see that too. You might have somebody, just a kid down the street who becomes an orphan and who ends up part of your family because somebody's got to take care of them, right? Yeah. And if you're in a loving, nurturing community, somebody will take that kid in and then they become part of that family, even though they're genetically not part of it. Right. So like I could definitely see that happening for sure.
Yeah. And one of the bigger concepts at play here too is, and we've talked about this a lot on this podcast, I've talked about it on other podcasts, but one of the neatest things about being an archaeologist, especially a field archaeologist, is seeing something that really makes you think about the moment in time that happened, right? The people that were living there, like even if it's just a small, lithic scatter with a broken projectile point sitting around it. The lithic scatter was just a pieces of stone, right? You can tell that somebody was out walking by themselves, probably trying to hunt, and then had to resharpen or do something to a tool and then broke it. And it sat right there with its little pieces and they just walked away. And they're like, stupid thing. You can see the temper tantrum. And it's just, and this is like, there was a family here that lovingly buried these people, these kids, and took the time to prepare them. And there was probably, even though, people tend to die young in harsh environments like this, but it's still a lot of grief. And they weren't that young.
Yeah. They were old
members
enough,
of the society at that point.
Yeah, they're not babies. They were old enough that they had full on personalities and were little humans that were important to somebody.
Well, and to put just a mechanical, element to it too. They were contributing members of that community too, probably.
Yeah.
So not only were they a loss to a family, they were a loss to everybody, in what they were doing and contributing, because kids weren't sitting back playing Sony PlayStation back then. Right. The boy was buried with a sword and the girl was sewing. Yeah. Come on.
Yeah. That's a very good point.
So yeah, it's a lot of investment in resources, not just to mention the emotional impact. So.
Yeah.
All right. So we're going to move from this one to another DNA study. And it's a really cool DNA study because it talks about how DNA has shaped more genes than we thought it has, or the study of ancient DNA and how it's changed through time. So anyway, we'll do that on the other side of the break. Welcome back to the Archaeology Show, episode 327. And we're talking all DNA all the time right now. So this next article is called Natural Selection Shaped Hundreds More Human Genes Than We Thought. Massive Ancient DNA Study Finds. First off, there's like more than hundreds of genes too. There's lots of genes.
Oh, like a lot more, but they were able to focus on specific genes to, draw some, you got to narrow it down somewhere, right?
You do. Yeah. So recently a large ancient DNA study found natural selection affected far more human genes than previously believed. So I don't know, this isn't in our notes really, but should we talk a little bit about natural selection and what that means?
Yeah, sure.
Yeah. So natural selection, obviously sort of first written down on paper, I think thought of by other people, but first written down on paper by Charles Darwin.
Yeah.
So when you think of Darwinian natural selection, this is what we're talking about.
Mm-hmm.
And quite honestly, a lot of times it refers to sexual selection.
Yes.
Like, who can make the best babies? I want their babies. And therefore, that person's DNA gets to get on into the future. Because to be honest, if you don't have babies, your DNA doesn't move on.
Yeah. And like, again, the origins of it all was, and I didn't do that on purpose, but On the Origin of Species was the book name. Mm-hmm. But Darwin was observing the behaviors of finches, I believe, right? Yeah. And
in the Galapagos.
In the Galapagos Islands. Yeah. And used that as the basis for animals selecting certain traits and then those getting passed down to offspring, and that being natural selection, because it does have a big effect on future generations, what is selected for, for who you're selecting for your partner, basically.
Right. Yes. So, and the way that actually works is, let's say somebody is, well, there's a couple cases here too, but let's just say somebody is like a really good swimmer and you live by the coast and they can go get fish. Well, maybe what makes them a good swimmer is their ability to hold their breath longer. Mm-hmm. And that would be a genetic trait. Mm-hmm. Like, you can train yourself to do that, but some people can just hold their breath longer because their lungs are different, they're whatever, mm-hmm. right? Well, over time, especially in like coastal communities, that would be a selected for trait because that would be a desirable person to have. Mm-hmm. Those people would find mates earlier and have more babies. Yeah. And those genes would get not only passed on, but again, modified through time and selected, because genes mutate. Yeah. It might take 1,000 generations for one mutation to happen. Yeah. But they still mutate and they still merge with other genes and do different things. So that's how that happens. Yeah. I mean, the nuts and bolts of it right there.
Yeah. I mean, super quick and dirty, obviously, because there's a lot of different things that we're not covering here. There's other ways that natural selection happens, which isn't based on sexual selection. There are other things like
well, like what we're going to talk about in this article.
Yeah, exactly. So let's get to that because
So the researchers in the article identified 479 gene variants under selection compared to just 21 in earlier studies. So they really upped the ante here.
Yeah, for sure. And they studied DNA from nearly 16,000 individuals, and those span 18,000 years, which was super crazy to me. But they had, they brought together these multiple different sequenced populations of ancient individuals. And the new ones included over 10,000 individuals from West Eurasia. So they're like bringing these multiple sources together and then doing this analysis on all of these individuals. So
that is the other thing you have to think about when you think about a study like this too. These all came from a single region, a big region, but a single region. Mm-hmm. And that's a different region than, say, North America, right?
For sure. Yeah. So we're only talking about what kind of natural selection happened with the populations that lived in this region over a gigantic amount of time.
Yeah, so it's probably something you can equate to a lot of the world as far as how things happen, not specifically what happened, right? Because that would have been different regionally, but how things happened and generally how this selection process really kind of works. Mm-hmm. So more than 60% of the identified variants are linked to modern traits, for example, skin color, disease risk, blood type, alcoholism, susceptibility, things like that, which is pretty cool.
Yeah, it's super crazy, right? That they're able to figure out what gene variant would have an effect on these traits. And there's still traits that we see today. And then like narrow those down in this entire population and then look for the natural selection. It's just the giganticness of this undertaking is just mind-boggling to me.
One of the things that they can see in this, which is pretty cool, is natural selection accelerated after the rise of farming. This is likely due to new environmental and lifestyle pressures. But one of those lifestyle pressures would have been, well, people living closer together and quite frankly, having fewer options than if they're like roaming around and meeting other tribes and doing whatever, right? But if they're now sedentary and farming, your cousin starts looking pretty good. Oh my gosh. And I'm not even joking though.
They didn't really talk about inbreeding so much.
But that wasn't even considered like inbreeding if you're talking to your cousin a couple down the road, right? Wow. Like that's just like availability. So...
Yeah, true. It's how you get certain traits that keep popping up because there is a little bit more inbreeding than like maybe there should be, but the population is smaller and that just happens. So,
and was it this article or the next one we're going to talk about that talked about the founder effect, which is a pretty common, I think it's this one. I don't see it in the notes here.
I think it is this one.
Yeah, but the founder effect is basically when you have a population bottleneck from a smaller, relatively new population that either A, had to move somewhere because of whatever reason, and now they're in a new place with nobody else around. That population bottleneck causes some massive genetic changes. Yeah. Because, well, people who, like I said, aren't normally getting together are getting together. Yeah. And their genes are getting together.
Yeah, exactly.
So, yeah. The other thing I like about this real quick is when you start, it's like, I think of ground penetrating radar, and I'll bring it all around in a minute. But with ground penetrating radar,
I'd love to see how you're going to do this.
I know. You see these like parabolas, and the average person can look at these signatures from GPR and not really know what they're looking at. Yeah. But people who are experts in this look at that and they go, oh, wall, coffin, whatever, right? Because they've seen those patterns before. So you can infer back from looking at the patterns, what you're seeing underground. Well, if they know what the rise of farming looks like in genetic differences, that's going to be a very similar signature anywhere on the planet. Yeah. So if you don't know when farming started somewhere, we probably do, but if you don't know, as an example, but you know what the genetic signature looks like, you can be like, well, farming probably arose here, unless that was something else. But when you start noticing the signature of something, you can start using that to infer things about other data sets, which I think is really neat.
It is very cool. Yeah. And just one more thing about the farming connection, like it is amazing to me how big of an effect that farming and being more sedentary had on humans. Like huge. I didn't even think that it would have had a genetic effect like this, but obviously we're seeing it in the increase in natural selection. So it's just crazy how much of an effect that technology had.
David Reich, who is a researcher at Harvard, was part of this study, or he was at least interviewed. I don't know. I don't remember. He wasn't the first author. I know that.
He's not the first author, but he did have things to say on it. Right. He's a senior author.
Okay, yeah.
And just coincidentally, this is not the first time we're going to talk about him. He's also in the next article. Yeah, he is. But anyway, that was an accident, and yeah, he's a big DNA guy.
He's a big DNA guy. Yep.
Do you think he describes himself that way? What do you do?
Kind of big deal in DNA.
I'm a big DNA guy.
But anyway, he says that the study highlights gaps in earlier research that lacked sufficient ancient DNA data. Yeah. I mean, people like to publish, but when you're talking about these kinds of things, you really need the numbers.
You've got to have tons of data before you can make these broad statements about populations over time.
Yeah. So a good example of how this natural selection really worked in, let's say, these farming populations. Is lactase persistence, which is basically why some people are lactose intolerant and some people are not. This lactase persistence, which spread in dairy farming populations, is basically your ability to continue to be able to process lactase into adulthood. Most species can't do that after they're weaned off of breastfeeding. Right. So, but we can because we like milk.
And that happened like in these dairy farming populations. That was a naturally selected for traits because they had so much milk and products that contained milk.
Well, let's be honest. Who wants to be around somebody who's pooping and farting all the time? That guy or girl is probably not going to get a lot of dates. Right.
We need to have a conversation.
So, but anyway, I mean, it's real though. Like if you're having severe intestinal problems because everybody else is drinking milk and you can't. And when you try, you just can't be part of the group. Yeah.
Well, even like bigger than just like the maybe social stigma piece of it.
It's big of it. That's part of it though.
If a lot of your caloric intake in your population should be from dairy and dairy products because that's what your community specializes in.
Be malnourished.
And you can't. Yeah, you are malnourished and then maybe you die young and you never have children. So that's the way natural selection occurs without necessarily sexual selection. That's just like you're malnourished and you die because you can't eat the thing that everybody else in your community eats.
You're like, I'm a vegan, and everybody else is like, all right, pack your bags.
I'm not saying that's exactly what happened, but
it's pretty close though, I would imagine.
Yeah.
I mean, there's a reason that trait was selected in. It means the people who didn't have that trait were selected out.
Yes.
That's the inference.
Yes, it is.
Whatever that reason is.
Yeah. Whether it was by choice because people didn't want them or by malnourishment and they couldn't.
Right.
They simply couldn't reproduce.
They simply weren't reproducing as much as the others.
Yeah.
That's what that means.
So interesting when you start digging into that and thinking about it. It's probably a combination of both, honestly.
Another thing this study did was it really just studied the ancient populations and their DNA, because earlier methods, according to the article, relied on comparing modern populations to the ancient DNA that they were studying. And you really just can't do that.
It was so different back then. Yeah. Everything was different. The way they lived, the foods they ate, everything.
Yeah.
And genetic differences can also result from non-selective processes like the founder effect. This is what you were talking about. Yeah. And this study instead tracks genetic changes directly over time using ancient DNA. So it kind of takes those variables out of the picture. Yeah,
they developed new computational methods, which is a fancy way of saying they probably used AI to separate true selection.
AI has a place, and crunching data is definitely one place for it.
Well, I'll tell you what, they will probably make some massive strides as computing power just continues to develop. Like when we start getting like quantum computers and stuff like that, I mean, these gigantic data sets, because one person's DNA is a gigantic data set.
Yeah.
And when you're taking, 10,000 of these and jamming them together and saying, let's talk about it. Like, how do you even do that as a person?
Yeah.
You need a computer to analyze these things and discover changes and trends and things like that.
The computer needs to just present all of the things to you on a platter for you to then analyze. But the presenting it on the platter piece, which takes a long time, can be done much faster by computers.
Yeah. So the first author on the paper, Ali Akbari, emphasized that the data allows scientists to observe evolution in real time, he says, which is kind of neat.
Basically the platter effect, right? Like present it all to you and then you can kind of see where you see the trends. I love it.
Yeah, one interesting thing about this is there was a key gene that they found called CCR532, which I think there's something in front of that.
It's a delta, I think.
Is that really a delta?
I think it is. I
thought in our notes it was like a mistake.
No, I saw it in the article.
All right, so CCR5 delta 32, which provides resistance to HIV and possibly plague, which that gene increased in frequency between 6,000 and 2,000 years ago. It actually went from about 2%, and I think I read it 8% in the notes.
Yes,
in the article.
I did read that.
And its rise predates the Black Death, suggesting earlier disease pressures, possibly endemic plagues. So there was some stuff that people were trying to survive, and some people were better equipped to it genetically than others. And they, of course, survived to make more babies.
Yeah, it's so crazy, right? Because like a rise from 2% to 8%, like that is gigantic.
Yeah, in population terms.
In population terms. And, from 6,000 to 2,000 years ago is a relatively short amount of time as far as DNA goes. So obviously there was some really serious pressure happening to get that, to have that gene selected for. And like we discussed before with the lactose thing, like people who didn't have that gene were dying and not having children. And that's why it was selected for, which makes you think it was giving them some kind of a way to survive whatever was killing people. So, so cool.
The last bit in our notes here is that they said it still remains difficult to determine exactly which traits were beneficial, as genes may be linked to other advantageous traits.
Yes.
So a passed on trait is not always a good trait.
Right.
It just means that whatever you have, either A, wasn't selected out and it's just being passed on with other things that were being selected for. But this is kind of like a side thing that just, came along with it.
Yeah, you can't think of each trait representing one gene or a group of genes. Like everything is all like mixed in together. And the example they used in the article is that it might be that one of these beneficial traits got carried along because something else that they liked, like maybe red hair, for example, was something that was selected for, by the people. Like people were choosing people with red hair as their sexual partners. Yeah. And then something else got carried along with it because, redheads were popular in Neolithic times. I don't know. They made that up in the article. We're making that up. But, that's how that works.
All right. Well, we're going to move to our last article, and this one's really interesting, and again talks about DNA, but it's interesting because we don't really know where Neanderthals came from.
No, we don't.
Like genetically.
It's crazy, right?
This new study actually suggests they may have come from modern humans.
Let's walk back the word study and just call it a theory from our favorite guy, David Reich, who was also quoted in this last article.
That's right.
But he's the DNA guy, so.
All right, we'll see what he has to say on the other side of the break. We'll see what Big DNA has to say on the other side of the break. Welcome back to episode 327 of the Archaeology Show. And as I mentioned, we're now going to go to another article here. Now, again, like you mentioned, this isn't really a study, but it's a really well-written article from the journalist that did this in the New Scientist. And it's called, Are Neanderthals Descendants of Modern Humans?
And this article is behind a paywall. So unless you have Apple News like we do, you might not be able to read this entire article. But that's okay. That's why we're here, to give you our synopsis of it. And then a quick note about the paper that they're referencing too. It is by David Reich, who we were talking about in the last segment. And he published this not peer reviewed. It's really an interesting tactic that he took. It's not peer reviewed, and he basically put it out there for comments. I'm not really sure why he's not going through the official peer review process. He will eventually.
Yeah.
He just wanted feedback and comments.
Yeah, basically.
Yeah.
The peer review process can take a long time, and it's somewhat limited too.
Maybe that's what it is, to kind of jump past that and get to the problems.
Right. I think he wants to refine this concept before he submits it for peer review, right? Yeah. So, because he's famous enough, he's got tenure, he doesn't care, he doesn't need it.
He's the DNA guy.
He's like, listen, guys, tell me what you think about this.
In fact, I think it said in this article that he wouldn't even give any quotes or do an interview because he's like, nah, I'm not talking about it yet. I wanted people to like have conversations about it, but I'm not talking about it as facts yet.
Exactly.
Yeah.
Which is, I can respect that.
Yeah, totally.
So let's talk about Neanderthals for a minute. They're basically just like people. Like we kind of make fun of them because back in, I think it was the 40s, and they were discovered in like the 1800s, I think, as a matter of fact. But like 40s, 50s, they were kind of seen and used in public, like cartoons and things like that, as
the
like
caveman image.
Caveman, the Cro-Magnon man, the Neanderthal man. That was just like calling somebody Neanderthal was an insult. Saying you've got a big forehead and you're stupid. Right? That's what it was. But they were not stupid.
No,
they were. I mean, living on the landscape with anatomically modern humans and possibly even Homo erectus if you go back far enough, but anatomically modern humans for sure. And they used medicine, they made art, they butchered large animals, they possibly crossed water with artificially designed craft. Every
single Neanderthal site that they find these days adds more stuff to that list of things that they did. Like the most recent one was that crayon, they called it in quotes. But art material, right? They're drawing with that. So
yeah, for sure. And despite this knowledge that we have of Neanderthals, because there's thousands of Neanderthal sites, we still don't really know where they came from genetically. Yeah.
Existing evolutionary explanations, well, they don't give us the origins. There's gaps. There's unresolved questions. There's just reasons why we just don't know for sure where they came from.
Yeah. Some people think that Neanderthals have formed through ancient interbreeding, which would have significantly changed human evolutionary models. And
we'll come back to that. This is the theory. That is the theory. So we're gonna come back to that.
So,
but first we need to talk about what we actually know about them.
Some more info about Neanderthals. They lived in Europe and Asia for literally hundreds of thousands of years. The oldest fossils are in fact around 430,000 years old from Spain. And those show Neanderthal-like DNA. So we might be starting to get kind of towards the origins of them here.
At that 430,000 mark,
Yeah, because it's not exactly Neanderthal, but they are. But Neanderthal-like is what it was described as.
Yeah, certainly probably an ancestor.
Yeah.
Yeah. And genetics suggests that they existed, quite a bit earlier than that too. And that would, going back to what we were talking about in the last segment, you can study the genetics and by the amount of complexity in the genetics, you can say, well, it needed this much time to get this complex. So we know that it was further back than that, basically.
Right. Yeah, there's two theories as to what's happened to them. Most people say they went extinct around 40,000 years ago, but I like the other theory that they actually moved to New Jersey and then eventually wintered in Florida to become Florida man. That's what I think happened.
Great. You just insulted probably a bunch of our listeners. Cool.
That is my goal.
Ignore him.
Yeah, I go for the New Jersey hypothesis, but really they probably went extinct around 40,000 years ago. Yeah. And extinct is an interesting term. It's like when you say a city collapsed or something like that. It's like, the people didn't, they went somewhere, but like what happened to them, right? Now, we really did breed out or whatever happened to them. There are no true Neanderthals anymore.
No, they definitely went extinct, but they didn't go genetically extinct.
But there's traces of their DNA in people today.
That's what I'm saying. It's like some of their traits were passed down and were passed to human populations and then passed down from there. So,
which is only one way that can happen.
Yeah, there's definitely interbreeding for them. So one of the reasons why they didn't survive is basically late in their history, climate changes reduced their genetic diversity by confining them to Southern Europe. So that was probably part of the reason why they went extinct.
Coming on 40,000 years ago, it was starting to get pretty cold in Europe.
Yeah.
Yeah, the ice age was coming down.
Yeah.
The glaciers don't grow overnight.
Yeah.
And the height of the last glacial maximum was, I think, back in the 20,000s in Europe.
Yeah.
Give or take, which means for tens of thousands of years, those glaciers were getting bigger and bigger.
Mm-hmm, exactly.
Yeah.
And a population really needs genetic diversity to thrive and succeed. And if their genetic diversity was declining due to not being able to spread because of the glaciers, then like that would be why they went extinct.
So, all right. So the standard genetic explanation regarding Neanderthals,
is and where they came from,
right? And where they came from is that they're closely related to Denisovans. Now, Denisovans are a somewhat contentious group too.
We don't really know where they came from either.
Well, they've been found. Remains of Denisovans, or what we think are the Denisovan people, have been found, I think, in Georgia and Ukraine, areas like that,
and further east, yes,
but
not further west into Europe. I don't think.
Right.
There's a really cool map in this article. So if you do have access to it, it's like a heat map of where these different populations lived. So to keep your eye on who was where and when, go look at that map.
Yeah, and what they say is both groups, the Denisovans and Neanderthals, likely came from one shared ancestor, something that they call Ancestor X. And this ancestor then split into basically modern humans, and a term I hadn't heard before, and I'm not really into the whole genetic community.
Yeah.
But Neandersovans, I've heard it. I remember when Denisovans were found. It was shortly after I got out of college, I think, or maybe when I was in college. And there was a couple of people really publishing a lot of blogs and things about it. That was a pretty big deal because it was 20 years ago, just about.
Yeah.
Not that long. Where we found a whole new human species.
Yeah, it hasn't been that long.
Yeah. But the fact that modern humans and these Neandersovans developed from what we're calling Ancestor X that we don't have any proof for. And then Neandersovans split into Denisovans and Neanderthals.
Yeah.
Right?
But the immediate problem with this theory is that we have no fossil that we can call Ancestor X.
Right.
So the ancestor to all three of these populations.
Yeah.
And we have no fossil that we can call the ancestor of Neanderthals and Denisovans, or Neandersovan, if you want to call it that. So the absence of evidence doesn't mean that you can't draw a conclusion.
Yeah.
It just means we might not have found it yet. That's the problem of archaeology, right?
Absence of evidence is not evidence of absence.
Exactly. That's probably what I was trying to say, but I'm really not good at remembering those exact words.
Yeah.
So that's the problem with this theory, is that we don't have the evidence to match it. It sounds good, but there's not evidence really.
Right. So who could be the ancestor?
Who could be?
So from the fossil evidence, because actual genetic evidence going back that far doesn't exist. It degrades too far.
Yeah.
You can look at the genetic clock, which is what these other studies have done, and see how DNA has evolved. But actually pulling the DNA from stuff that's 500,000 years old or older is really difficult, if not impossible.
Yeah.
So Homo erectus is an obvious choice as an ancestor for all of this, because Homo erectus was around for millions of years and spread out of Africa up into Asia. We have Homo erectus fossils in Asia.
Yeah.
I'm pretty sure we don't have any in Europe. Yeah, that's right. So in our notes here, spread widely outside Africa, but lacks confirmed European fossils.
Yeah.
Right? So they went up through the Levant, through, Israel, that whole area over there.
Yeah.
And then just continued on up. And one of those reasons is because of the mountains, to be honest with you. It would have been difficult to cross Turkey and over into Europe.
Yeah.
It was easier to spread the other direction.
Yeah.
Right? It's not to say some of them didn't, but enough of them didn't that we don't have evidence for it.
And they do recently, and this is just in 2025, they found some remains that they're calling Homo AFF period erectus, which was another new one for me. But
me too.
That's taxonomy speak for we think they might be this, but we're not remotely sure. Yeah. So they have some kind of maybe possibly Homo erectus remains.
What did you think it was? Homo AF?
I did. I was like, but it's not Homo AF.
It's Homo AFF.
It's Homo AFF. Yeah.
Yes. Homo AFF was BF with DF, and then no. But Homo antecessor, which is another option, is found in Spain. There's protein evidence that links it to what would be Ancestor X, the as to undiscovered Ancestor X.
Honestly, this one seems like the best option to me. But the biggest problem with it is that there's only one site.
Yeah.
I think there's 6 individuals.
Something like that, yeah.
Something like that. So like, that's just not enough.
Yeah.
You need more fossils to say somebody's an ancestor and then build an entire family tree off of it. You know?
Yeah. So we don't really know where that one fits.
Yeah.
Also, Homo heidelbergensis, which you may have heard before.
Yeah.
We don't really know where that one fits either, because it was once a leading candidate for all this, but there's too few fossils and too recent too.
Yeah, a lot of them have been recategorized into other species lately, and like basically we just don't have enough now.
Yeah.
And it seems too recent too. Like this needs to be an older fossil. So
Yeah. So overall, there's no clear fossil ancestor, and there's a lack of DNA, which limits certainty for this. Yeah. So, all right.
So genetics does suggest a split between modern humans and Neanderthals 500 to 700,000 years ago.
Yeah.
So we're looking for an ancestor that's potentially before that, right? For ancestor X.
Yeah. And geography is pointing to a possible origin in Western Asia.
Yeah, because that would make sense.
There was a lot more going on over there.
It's like coming out of Africa. We know the oldest ones are coming out of Africa, right?
Yeah.
So like that would be the logical spot.
Yeah.
Just a very general region.
Yeah.
They even say it right in the article.
And there are some fossil finds out of China and Morocco that are complicating the picture either too, because they're just adding to this big puzzle that we just don't know. We don't know what the picture is that we're building from these puzzle pieces yet.
Yeah, so, exactly. Yeah. But there are some things that we do know.
Yeah.
We know that Neanderthals and modern humans interbred. And that interbreeding happened multiple times over a really long period of time. There's some older interbreeding evidence, and then there's some younger interbreeding evidence. Yeah,
and modern humans, as we mentioned before, have some Neanderthal DNA. There are people with Neanderthal DNA walking around today, right now.
Exactly.
And we know that for a fact.
Yeah, what was the joke? Like everybody submits their DNA to one of those like 23andMe or whatever, and they come back 1 to 2% Neanderthal, like most people do.
Yeah, right.
Which is crazy, right?
Yeah, and Neanderthals themselves anatomically show signs of modern human DNA.
Yeah.
So
not just anatomically, like in their DNA. So again, interbreeding for sure. And where did that modern human DNA come from? Yeah. We don't know.
There are some unusual genetic patterns that go against the grain from what you would expect from all of this, like the loss of Neanderthal DNA from modern human X chromosomes.
Yeah.
The replacement of Neanderthal Y chromosomes and mitochondrial DNA with modern human versions. So there's been some sort of weird mixing that we don't really understand.
Yeah, that second one is what really gets me, is like that Neanderthal Y chromosome and the mitochondrial DNA was Neanderthal and like different and Neanderthal specific at one point, and then it became the modern human like version. Yeah. So interbreeding, obviously, but like when, where, how, all of those questions are still out there.
So enter big DNA man, David Reich.
Oh, God. I really hope he never hears the show. He's going to be like, who are these two people? They don't even know what they're talking about. We don't. It's fine. We just try.
His name is David. Should we send him a t-shirt that just says big D and then small NA right after that?
Everything is wrong with that. No.
So his theory is that early modern humans.
Yes, modern humans.
Not
Homo erectus. Modern humans.
They left Africa and interbred with local hominins, we'll get to that in a minute, in Europe 400 to 250,000 years ago. Hominins, we've just mentioned like 5 different species living in modern Europe at that time.
Yeah.
Hominin represents all of them.
All of them.
Yeah.
So like Heidelbergensis would be one, right?
Yeah.
Antecessor, like all of those are, especially like antecessor, where they only have that one example in that one place. That's a local hominin population that lived there.
Yes. And so they interbred with all these other species. And then the hybrid descendants of those other species, some became Neanderthals.
Yeah. These hybrids retained the modern human Y chromosomes and the mitochondrial DNA that we were just talking about.
Yeah.
And this is a complete reframing of the origin of Neanderthals. Not as a later event, because remember in the beginning, we were talking about Ancestor X up at the top here, splitting 2 branches, one to modern humans and one to Neanderthals and Denisovans, and then down from there. And then this interbreeding happened down below on these lower levels of the family tree.
Yeah.
Now what David Reich is proposing is that we have a modern human come out of Africa, interbreed with a bunch of different populations that were already there. And then we get modern human, we get Neanderthal, and we get Denisovan coming off of that. And Neanderthals go into Europe. Modern humans I'm not really sure where modern humans go. I think they kind of go all over.
Go everywhere.
They go everywhere. And maybe not right away, but they eventually go everywhere. And then Denisovans go towards Asia more. So just like it sounds like such a small thing, but it's like a complete reframing of this entire idea.
Yeah.
Yeah.
So what supports all this?
Yeah.
Well, he's getting this because of a few different things that are aligning to make this theory work. One of those is the shared use of the Lavoie tool in Africa and Eurasia.
Yeah.
This supports migration and interaction. And the Lavoie tool, it's a whole thing. Big hand axes. They've got some pieces there. You can really tell what one looks like when you know what it is.
Yeah.
And if you want to look it up, it's Levalllois. It's actually, I think, a French word. But anyway, they've been found all over the place. Right?
They have. And I think the running theory has been they just were developed independently of each other by different groups. Which doesn't always make sense
but it does to me. There's only so many ways to make a stone tool.
Yeah.
I'm like, somebody's going to happen on this idea.
Yeah.
You know, but my problem has always been with the Clovis technology. It's like, yeah, I understand it's somewhat unique and it developed around the same time.
Incredibly unique.
Well, okay, sure. But the fact that those stone points span 2 continents over the course of a few thousand years, did those people really take this all over the place and then somehow disappear? And turn into other people? I mean, I'm just like, what happened, right? Like, why wouldn't they continue doing this?
It's just that it developed into something new. We don't have to talk about that now.
It's one of the only stone tools in the entire Western hemisphere, well, at least North and South America, that just like is consistent across both continents. You know, at least the one that they say is. But when you're an archaeologist and you worked in over 25 different states in the United States, you see that, hey, there's other tools that look very similar too. They just have regional names. They haven't been given national names.
Well, that's true.
Because there's only so many ways to flake a tool.
All right. I'm not going to debate, lithic typology with you right now.
It's the same thing. And I don't think it's a strong argument, but it is one of the arguments for this because it does indicate maybe at that time frame a little bit of migration and intermixing and things like that.
It helps to support this theory. Yeah. I'm not against this idea because it does mean that modern humans developed the Lavoie technology in Africa, brought it into the Levant, Europe. Middle Eastern area, and then it went to Europe and Asia from there. Like that naturally makes sense. Yeah. So, yeah.
But we are talking several 100,000 years too that they took them to do that.
We are.
Things get lost and I don't know.
Yeah.
All right. So, and that's why they even say this hypothesis is tentative and it may not fit all timelines, right? There's an acknowledgement there.
Well, this is exactly why David Reich decided to put this out publicly to get feedback and hear people having arguments against it. So he can either be like, oh yeah, that's a good point. This would never work because of that reason. Or he can be like, I hear your argument. However, this is how I would refute it, and go find the evidence to refute it. So
I know in our notes summary too, it says this reflects a broader view that human evolution is complex and shaped by interbreeding. I'm like, did we need science to tell us that? I mean, I know we need the confirmation.
That was just the nice, neat and tidy conclusion of this article.
I probably would have started with that and just tried to prove it. But yeah. But anyway, when you put all this together, it looks like, if true, Neanderthals might be partly descended from early modern humans, which is kind of neat.
It is just such a crazy idea. So, okay, let's say that is your new theory, right? Neanderthals descended from modern humans.
Yeah.
What or how do you go and look for evidence of that in the fossil record? Or can you? Is there a way?
I think in some cases, you got to dig deeper, first off, because you're talking about further back in time. So the common problem archaeologists have is you hit like true sterile levels in some places, like here in CRM in the United States, and you stop digging, right? But in other cases, you might be like, okay, well, we found all this. Well, let's see what's a little further down and see what we can find. And then also not make assumptions too, because people find little tiny bone fragments and things like that. And I think they're too quick to want to lump them into a category rather than putting them in an unknown category until we can analyze them further. Time and time again, we see articles about museum collections getting reanalyzed and completely reclassified.
Yeah, I was actually just going to say that because I think that everybody has approached Neanderthals with the Ancestor X idea. And if you reanalyze all of these collections from a Neanderthals descended from humans place, would that recategorize things? Would you find your evidence in fossils that already exist?
Right.
By doing that. But then again, you also got to be so careful to not make things fit you don't want to force the puzzle pieces to fix. They need to fit naturally. And it's so hard. I don't know how people do this kind of work. I would be constantly terrified that I was categorizing something wrong or putting something in the wrong place, and I would never be able to make any decisions. I would be paralyzed with indecision all the time. Shocker. I already am. So. Shocker.
Yeah. For those that don't know Rachel, this is not new information.
I'm self-aware enough to know who I am. But that would be hard for me personally. Yeah.
All right. Well, the point of the story is, if we ever develop space travel and you are on the Battlestar Galactica and you go back and you go to a planet that happens to be Earth. Did anybody see the end of that movie? That series?
Oh, yeah, that's right.
They're like 200,000 years back in time.
And by anybody, did you mean me? Were you just waiting for me to catch up? Because I can't.
Yeah. I've always been intrigued by that ending.
That ending, I blocked it out because it was the worst part of the show for me.
Well, because until that point, you think that this starting point for humanity or whatever is actually Earth, but it's actually not.
Yeah.
And humans, which would blow the whole Neanderthal theory out of the water, but anatomically modern humans are actually aliens that came here from another place.
I've just washed that whole thing from my brain.
This actually goes into, I just rewatched Interstellar last week too.
Oh,
that's a great movie too, because
in a long time.
Yeah, you find out that, there's this wormhole that develops because Earth is in a bad spot, and, everybody's going to die because of famine, because there's dust storms, and we've done bad things to the planet, right?
Mm-hmm.
So a few people go out into space because this wormhole developed through near Saturn, and you can go through this, and there's 12 habitable worlds to discover on the other side. And they're like, who possibly sent this information? It must have been aliens that are helping us out.
Right.
But turns out it was us in the very distant future, just solving our own problems.
Yeah.
Right. So, which brings up all kinds of time travel questions and how do you know, and blah, blah, blah. But anyway, there's a whole bunch of things, but it turns out it wasn't aliens. It was just us. Right.
Yeah.
So turns out it wasn't, some weird ancestor of Neanderthals. Maybe it was us.
Right.
We did it.
Okay.
Yeah. It was our breeding that did it.
Yes.
All right.
Makes sense.
All right. With that, we'll see you next week.
Okay. Bye.
Thanks for listening to The Archaeology Show. Feel free to comment and view the show notes on the website at www.archpodnet.com. Find us on Facebook, Instagram, and Twitter at ArchPodNet. Music for this show is called I Wish You Would Look from the band Sea Hero. Again, thanks for listening and have an awesome day.
Thanks for listening to this podcast. The Archaeology Podcast Network's chief editor is Rachel Roden. Our executive producer is Ashley Airy. Our social media and newsletter coordinator is Matilda Siebrecht. The APN was founded by Chris Webster and Tristan Boyle on December 1st, 2014. We're supported by our amazing podcast hosts, many volunteers, and listeners like you. Check out membership at www.archpodnet.com/members.
This has been a presentation of the Archaeology Podcast Network. Visit us on the web for show notes and other podcasts at www.archpodnet.com. Contact us at chris@archaeologypodcastnetwork.com.